Merhaba, nasılsınız? İyi? Okay. Benim adım Mohammad. I am a civil engineer from Lebanon. I just know a little bit of Turkish because I love Turkey, so I started learning Turkish this year, still in the first course. Okay? Today's sessions is about infrastructure. The first session will be about rail design. The second one, we will talk about road rehabilitation. And the third one is going to be about construction planning. How we can use InfraWorks to basically manage the construction site and analyze how we can, for example, lay the site, get the construction vehicles into the site, etc., etc. Okay? So the first session is about rail. And as you know, we have too many rail projects going in the region. Specifically, if you go to the Gulf states like Qatar, United Arab Emirates, you will find a lot of projects, and even in Saudi. Definitely that's the same case in Europe as well. So today's agenda will be like this. We'll go about what is rail. We'll start what is the situation, the current problems, what is the industry terminology for those of you who don't know about rail. Then we'll go about the rail project's workflow, because with Autodesk, we have many different tools, many different software. And these tools speak to one another. So we start with one, we move to another, to a third one, and so on. And finally, hopefully we'll have some time for questions and answers. So why rail and why is now? If you check worldwide, there are many studies done by companies like McKinsey and others about the investment in rail projects. So if you look, for example, here at this part, okay, I don't think it's working, but this part over here is about rail passengers per kilometer per minute or per hour. You see that there is an increase with the trend from 2005 up to 2025. All of the countries in Europe, even in Canada and the States, are investing heavily in rail. And the biggest investment in rail is being done currently in India and China. In the Gulf region, there was a very optimistic project of connecting all the Arab Gulf states together, but due to the fall in the oil prices and the tensions over there, they stopped it for the moment. A lot of investment is going in Europe, and there is the European Union connecting all of the major cities in Europe all together. Even in Africa, if you check the studies about Kenya, about East Africa, and even North Africa, we do have a lot of projects involving rail over there. So billions, hundreds of billions of dollars are being invested into rail projects worldwide. Another example of a very futuristic project, I don't know if any of you heard about the Hyperloop project in Dubai. It's basically connecting Dubai to Abu Dhabi. So what they're planning to do is connect the capital, Abu Dhabi, to the city of Dubai using a very futuristic technology of a tube with cabins that move at the very high speeds. So by just booking your cabin, you're able to move from Abu Dhabi to Dubai in a matter of minutes. Usually nowadays, if you're going from Dubai to Abu Dhabi, it will take you around 1.5 hours. They're planning to have this time reduced to around 12 minutes, so just 10% of the time. And this project is actually being tested. So the company that's working on this Hyperloop project, they've developed some prototypes, and they're checking those modules or those cabins inside the pathways that you will see in a second at a very, very high speed. So these are the modules which people get into, and these modules move into a certain container, and then that container goes at speeds of 500, 600, and maybe more kilometers per hour. So this is where we're heading. This is a rendering of how the Hyperloop tube will look like. And as you can see, they're tracking the time over here, from the time the person goes from Abu Dhabi to Dubai, till the time he gets to Dubai, and that is going to be monitored definitely with stations and other things as well. So reducing the travel time by 90%. So a lot of disruption, a lot of new technology, but what are the problems? So we do have a lot of problems nowadays in our world, and it's more often that the engineers working on vertical construction, like architects, who probably will design the metro stations, and the civil engineers who are working on the rail tracks, the horizontal alignment, would like to coordinate or collaborate together. So the major products from Autodesk that highlight those issues are definitely Revit for vertical. We have Civil 3D for the rail tracks. We have the BIM 360 platform for collaboration, and Navisworks for clash detection, and definitely InfraWorks for project communication, visualization, and things like that. If you look at the official Autodesk presentations for rail design or rail projects, you're going to find something like this. I'm not going to bother you with this. I've developed something more enhanced, which I will share with you in a couple of minutes. But definitely, like any other construction project, we go from planning to conceptual design, detailed design, and definitely construction and handing over. Okay? As I mentioned, this is the typical workflow. We start with some planning or conceptual design in InfraWorks. We move the rail design to Civil 3D. We design the stations in Revit, and then we can collaborate on all of these models in BIM 360, for example, Docs or Navisworks. We do have another component to the mix, which is Inventor. Autodesk Inventor allows us to create parametric objects, which we can use in the design process of rail tracks. So what about the rail terminology? For those of you who have never worked on rail projects, just a very quick introduction. Since we're into designing the rail tracks, you see over there we have two rails. We have the sleepers, which are basically like threads or plates that hold the rails together, and we have the ballast material, granular, that sits underneath, which takes all the vibration, all the motion from the metro or the train. Okay? And then we go about designing the rail tracks. Same like we have terminology for road design, we have another for rail track. So in road design, we talk about super elevation. In rail track design, we talk about cant. So cant is the counterpart of super elevation, and it's basically the difference between the two rails. So these rails are above one another. What is the difference in terms of height? The switches and crossings are basically any intersections between the rail tracks. And there are many different types of them. Turnouts, diamonds, crossovers, slip diamonds. Think of them like the different types of interchanges or intersections we have in road design. And these are being selected depending on the speed of the train, the situation, the surface, and other aspects as well. So just to give you an example of a switch, as you can see, this is a switch, and it's basically changing tracks, and the crossing is further ahead to direct the train to move from one track to the other. These also, we can model them and design them nowadays inside of Autodesk Civil 3D, for instance, along with the cant component as well. Now, rail projects are various. So we have the high-speed rail, and this is usually going at 300 kilometers per hour. We have some of them in Germany, some of them in Japan, and other countries as well. Most often, we're having the light-speed rail. So anything like a metro or a tram network connecting the city neighborhoods together. And definitely the freight rail for moving heavy objects or big components. So that was a very quick introduction about the rail terminology. What I've put together is what we as Autodesk would advise people or designers to do. So I've started with the project planning phase, and I've highlighted the tools that we usually use during that phase for rail design and for what reasons. So if you look at project planning, we would like, for instance, to have an idea about the existing conditions. How do we get all the surface data? What are the objects, the buildings, the city furniture like street lights, etc. The GIS integration, because most of the municipalities or governmental authorities, they have the data stored in GIS platforms. How can we bring that data, put it inside of InfraWorks, and start the planning process? What about suitability and feasibility analysis? What is the best alignment for that rail track or rail network? How we can leverage the 2D and the 3D world together, and definitely check some estimation about the land usage. because this track is going to pass through certain lands or territories, and maybe we need to acquire those lands or purchase them from their owners. All of which can be done using tools like Recap, InfraWorks, and Civil 3D. Once we move into conceptual design, we're going to use InfraWorks and Revit or Format, if you need, to design the conceptual rail track and the station. So I'm not going to go into each one of them, because we're going to cover them shortly. We move from conceptual to detailed. This is where we use Civil 3D instead of InfraWorks, or we take whatever we have created in InfraWorks and we'll use it in Civil. For the design review process, we use Navisworks Manage, ideally, or BIM 360 docs in the cloud. For communicating the project to a stakeholder or a client, there are multiple ways. We can generate snapshots, we can do storyboards, animations, we can push that model to VR or reality, virtual reality experience, etc., etc. There are many ways we can do so. And I'm going to share with you one interesting case from Europe about virtual reality for rail projects. And definitely, to tie all that together, we need some sort of a document management system, right? Because too many stakeholders are working on this project. They will share documents, they will share models. They need to communicate. And this is the recommended platform as BIM 360 docs. I think most of you already know about it. So that's typically the workflow with the tools and the capabilities or challenges. So if we move to project planning, and by the way, this screenshot is taken from InfraWorks. How many of you already know InfraWorks? Can you please raise your hand? How many know InfraWorks? Not too many. Okay. So in my second session, I will open InfraWorks. I'll do something cool with it and let you know more about it, because we have more time than this session. Okay? But basically, this is a sample conceptual rail track taken from InfraWorks, a screenshot taken from an InfraWorks model. So why InfraWorks for conceptual design of roads, bridges, tunnels, and rail tracks? Because InfraWorks is a relatively new and advanced technology, not based on AutoCAD, but based on. So we are able to create models that are huge. So we can go up to thousands of square kilometers. So imagine if you want to have the whole model of Istanbul, or even the whole model of Turkey in one single place, you can do so using InfraWorks without having any crashes or any problems. The same goes about aggregation of data. So we can bring data from any source, whether you're an architect working with SketchUp, with Format or Revit, or even you have a model in 3ds Max, you can get that model, dump it in or import it into InfraWorks, and you will have that model showing in its right location to the right scale with the right material. So these are just few benefits of using InfraWorks. And the technology of even capturing the existing conditions is evolving. This is just one piece of equipment provided by Leica, and what they actually do is basically scan existing rail tracks, and then to an accuracy of 1 to 2 or maximum 3 millimeter, and then converting that scan of the rail track into a BIM model, which can be leveraged later on for facility management or even for maintenance or anything that you can think of. So there are dedicated tools for the rail project, starting by capturing the existing data like this, or even by bringing the data into different platforms like Civil 3D and InfraWorks and others. I'm just going to skip this. So how many of you already know about laser scanning? Please. Laser scans, point clouds. Okay. Also not too many. Okay. If you want to know more about laser scanning, there are 2 major webinars delivered by Autodesk employees, and these are they. They are available online on the InfraWorks YouTube channel. So if you go to the InfraWorks YouTube channel on YouTube, you will have too many different videos about the topic. Unfortunately, we don't have time to cover it today. Maybe I'll cover it in my upcoming session. So once we use a laser scanner instead of a total station, for those of you who know about surveying, instead of having a static equipment that basically reading a certain point over there, no, I just place a laser scanner in the site, and the scanner will scan the whole site in a matter of minutes, bringing back to me billions of points. So instead of capturing single points, no, I bring billions of points with all of their intelligence. And that intelligence can be then transformed into a BIM model, or even, as you see at the right bottom of the screen, a classification of the point clouds which I can leverage in many different ways and formats. For example, I can scan an existing metro or railway station, and directly inside of InfraWorks, the software will detect the rails themselves. I don't have to be smart or pick points. I can even check the cross-section using the point clouds. And if need be, I can place certain points, create what we call like break lines, which I can use later on in the Civil 3D platform. So this is just an overview of capturing the existing conditions. We have the existing conditions. Let us start with the planning of the project. Since this year, anybody who basically has an active subscription of AEC Collection will have a free license to access the ArcGIS online database. By doing so, you will be able to pull that data from the cloud inside of InfraWorks and then develop it into a 3D model inside of InfraWorks. So this is just a 3D representation of whatever GIS data is in the cloud, enhancing the planning process. We can also leverage something called suitability maps. So we already know the rail project consists of rail, tracks, and stations along the way. This simple tool within InfraWorks allows us to put some metrics or criteria. So if I move just the video a little bit forward, I can specify buildings. I can specify, for example, any other features like major roads or structures. And then I will ask the software to highlight in a heat map where are the best locations for me to place my station. I want my station to be very close to stadiums, to schools, to places where people will gather in big numbers. So it's going to run this analysis based on a simple criteria with weights, and the end result is something like this. So for instance, the best location would be somewhere around that red area. Anything that is blue maybe is not valid, or maybe does not serve the purpose. So again, helping us throughout the planning process. What about bringing in 2D and 3D master plans? Most governments worldwide, they will have master plans in 2D, whether AutoCAD or even raster image. Although InfraWorks is a 3D BIM tool, it can actually bring that data in and put it or superimpose it on the 3D model, as you can see from that video, with all of the colorings and the required information. The same applies if we have something like AutoCAD. So we have a master plan in AutoCAD, even if it's 2D without elevation. We just bring it into InfraWorks, and using what we call rubber sheeting process, we pick certain points, point 1, 2, and 3, and we basically correlate, or we transform the image to fit the model that we have in hand. And then from there onwards, we can start to plan our track or the placement of our stations. So we're getting the point clouds, we're getting the 2D data or 3D data, we're getting the GIS information. It's the era of information anyway, and this is what differentiates BIM. So we've done the planning. What about moving into conceptual design? We want to start as designers to plan something real, in real life. So we have too many different ways. We can basically use the rail track that is planning sort of thing. So very quickly inside of InfraWorks, I'm using the basic functionality over there. By just clicking on that, it has also made the crossing. I can make changes to the elevation if I need to have maybe an underpass underneath, and basically be able to visualize it and understand how the project looks like, what is the total length of the rail track, etc., etc. This is the lowest capability in InfraWorks. This is not the recommended workflow. This is for someone like a planner in a governmental entity who wants just to sketch something very quickly. The best way to do it is using something else which we call component roads. So the software is going to create some intersections, but there are some limitations which we need to overcome. We definitely not only support the rail tracks that are on the surface, but also above and underneath. And if we have any tunnel, using some parametric modeling, we can change the shape of the tunnel, the width, the height, and other parameters as well. Now the problem with this approach, using the planning rail tracks, is that we cannot bring that model into Civil 3D. That's why I said it's very good for only quick master planning. So these are the limitations. And then we move into what we call component roads. Component roads are the most advanced and intelligent roads inside of InfraWorks. We activate them from the road module over there. Okay, so let me move just a little bit. Okay, so we move to the road module. We pick component roads or design roads, and then we can pick certain dots over here from one place to another to create the rail track over there. This is actually an old video that I've created before component roads were introduced. But you will see that you're able to change the style more often. You can change the geometry because you have elevations. It will create intersections and other stuff as well. So let me suppose I want to create an overpass over there. I can apply, for example, a bridge from this station to that station, and a sound bridge will be there with the deck, the pier, and other components as well. In this case, maybe because it's a very short span bridge, it did not create any piers, but we can add piers if we need to. Sometimes we need to bring an alignment that's done in some other software, maybe not an Autodesk software. So at Autodesk, we're developing those charts to let our customers understand how is the workflow from one tool to the other, and what are, for instance, the file formats that we can use to move data from one software to another. That's very useful even for designers or engineers. So just an example, we have a polyline that resides in Civil 3D, right? But this is just a polyline. There is no corridor, there is no intelligence whatsoever. So we can break that corridor, that polyline into certain segments, and then we can basically import it into InfraWorks. So just to save you time on the editing part, we come to InfraWorks. We link into the Civil 3D model. Here, as you can see, we're opening the exported polyline from Civil. We're just assigning a style, and that style can be based on a certain criteria or a query language. We want it to be on the grade or above. Just minor configuration. Once we hit the apply button, we're going to see our rail track showing in 3D as a 3D model inside of InfraWorks. So this is another way of showing whatever is 2D in 3D in a 3D environment like InfraWorks. Another thing, what if we have a rail track and we're using the design roads? I'm going to skip this because it does not apply anymore since 2019 design roads, InfraWorks 2019 design roads is not anymore supported. So this one does not actually work anymore. We don't have that capability. Basically, we were able to do some more editing regarding the style. What I care about is the component roads. So how can we create an intelligent rail track using component roads? And again, we have major benefits of using component roads, but I'm not going to talk about it later. If somebody is interested, I can share with you the presentation later on. So with component roads, as you can see, we have detailed rail tracks that also have maybe underground components. And that component road will also give me as a designer all the required annotation. What are the stations? What is the curvature at a certain point, etc., etc. It will also help me create the necessary grading. So depending on the type of material, the cut or the fill, I can specify. For example, the cut stability slope is 3:1 or 1:3. The fill slope is 2:5, for example. And once we apply it from one station to another, it's going to update the whole model. Not only that, we can change the type of component for material takeoff issues and for visualization issues. As you can see over there, just simply click from one station to the other. I can definitely apply a style to one track or both tracks or all tracks at the same time. So making some modifications, as you can see, the update is directly in 3D. We have sections inside of InfraWorks because we want to design not just in a 3D environment. As designers, we would like to see the cross-section, understand how is the profile or the cross-section doing in terms of cut and fill. We can exaggerate that like we do in Civil 3D. All the necessary tools, basically, to get all the quantification and required analysis. Also for visualization, we can add components. So sometimes we have those gantries that basically provide electricity or power to the rail track. We can place it in its right location or even give it a certain offset numerically. And InfraWorks automatically is going to place that along the path of the rail track, depending on the criteria that we basically put in there, as you can see. So it's all parametric modeling. We input a parameter and everything updates in 3D. Once we get that right, we can move further for visualization purposes and then animation. So what if we want to create an InfraWorks 3D rail component from an AutoCAD? So remember, let me just go back one moment. So in this video, we had a very specific rail track design. So let me move a little bit here. As you can see, we have only one track, we have one type of a gantry, we have a certain width, certain type of sleeper. Remember, the ballast material that sits underneath. What if we have a certain design that's recommended here or required here in Istanbul or Turkey? This is how we do it. If it's not provided by the client or the owner, very simple. We can create a very small section of it in AutoCAD or AutoCAD Civil 3D, as you can see over there, basically a 3D model. Export it to SDF or FBX file format, and then we read it into InfraWorks, as you will see here. So here, I'm just creating a component. Think of it like sub-assemblies in Civil 3D, for those of you who use the sub-assembly composer. I'm doing something similar in InfraWorks, but it's highly visual, extremely easy to do, and you can see by just picking some tips and clicks here and there, I'm able to create the ballast material with the right slopes, see the effect visually, add as many components as I like, bring in that 3D model that I've created in AutoCAD, and then it's already saved in the library of InfraWorks. Here we just ask, please InfraWorks, add this component, and as you can see, it's available, 3D model. Where do you want to place it? At which location? Maybe we need some rotation over there. So basic 3D modeling. But the good thing is, this is in 3D, taking in the materials, taking in the exact length, height, and width. And once we're done, just to save your time, we're going to end up with something like this, which we can basically save. See here? So I'm going to save it. I want to save that sub-assembly or that cross-section into my library, and I'm going to use it as a designer in all of my upcoming projects. So you do it once, you use it all the time. That's the power of BIM. What about project analysis? So we've modeled something in Civil or InfraWorks. We created the rail track, but we want to give a feel of how much it's going to cost. So with very few clicks, we go over there to the calculator after picking the rail track, and we get a full quantity takeoff of all the components used in that rail track. And remember, it's not just the rail track itself. Even if you look over here, any portals, any of those gantries or any signboards or any equipment you put on that rail track will be quantified in a few seconds, which you can basically hit the generate report button, and that will fire up a CSV file, or will basically save it as a CSV file, which you can open in Excel. So definitely if I change the width of all the columns, I'll have each and every component, what is the width, what is the height, what is the volume of that component, which then I can link into an estimation software for cost estimation purposes. So also within InfraWorks, we do road design, bridge design, rail track design, but also we can analyze the watershed analysis. So instead of just picking a point, we can analyze the whole area, and using the power of the cloud, of the infinite computing, Autodesk will send you the watershed analysis for your entire model. This process will take a couple of minutes, but for that area we've selected, you can see what is the area where the water will fall. The black lines are the streams where the water will collect and basically intersect with the road. So you as a road designer or a rail track designer, you will know that at a certain point, for instance this one, you need to have a culvert or a pipe that will take the flow from one side to the other. So InfraWorks is helping you with the analysis and detection of those critical points. Not only that, it will also help you to design them. So with a single click, you can design those culverts, and basically, as you can see, it's a 3D structure. So these are the critical points. And then we'll help you design the culvert itself, and then we'll provide you with the hydraulic report. So you don't have to be a hydraulic engineer or a hydrology engineer. It's giving you the upstream, what is the flow, what is the volume, and the downstream. If you change the number of pipes or barrels, how would that affect the flow of water inside those culverts? There are many, many powerful drainage design tools within InfraWorks. This is just one. Once we're done with that, we're going to do some land calculation. So we're done with the conceptual or preliminary design inside of InfraWorks for a rail track. And by the way, we can edit the profile very quickly, like we do in Civil. We bring that model or that alignment into Civil 3D, and using the Map 3D functionality of GIS, we put it on top of the parcels or lands, and we check the intersection with the right-of-way. So this rail track with the right-of-way, how much land should be consumed or acquired. And that actually can be generated into a report. And finally, we can bring it back into InfraWorks for visualization. Getting the existing conditions, planning, conceptual design, what about detailed design? So in detailed design, this is where we use two major products. We use Revit to do all the structural components like the metro stations. So for example, the Qatar rail project, which is worth about $40+ billion, all of the metro stations in Qatar were designed using Revit. Deutsche Bahn in Germany, same thing. There is a study published online. I think it's in German, if I'm not mistaken, but you can check the link, and there are also Revit models from some of those stations available online. This is just one of them. So you can download that simple station and have a look how Deutsche Bahn used Revit to design the metro stations. So that's for the vertical or structural components. Then we have to do the horizontal component. Since 2019 or 2018.2, we're starting to have more rail design capabilities inside of Civil 3D. One of which was creating the rail turnouts, and recently we are able to support the cant and sub-assembly composer. Again, another chart, but I'm not going to waste your time on it. Inside of Civil 3D, we go into the details. So we have the conceptual rail track alignment. We use the sub-assembly composer, or if we have any other assemblies saved, to create the corridor, to change maybe the alignment, and definitely generate all the construction documentation. Plan, profile, cross-section, what have you. So this is just an example from the latest webinar that the Autodesk people posted online. I highly recommend that you go on YouTube and check for the videos, specifying step by step how you can basically create an alignment inside of Civil 3D for a rail track. So you find at the top there is a rail tab, and then you specify your parameters. With the cant calculation, you have a tabular format, which if you change, everything in 3D will update. You generate the profiles like we do with road design. And you can definitely create a corridor and cross sections as well. Now we do have built-in sub-assemblies for rail, and this was introduced recently, and we can change that sub-assembly visually also and physically to target into certain objects. We can also create sub-assemblies for things like overhead or rail tracks going above the ground in a bridge format or even tunnels. And all of that serves not only for the purpose of quantification only, but also for the construction documentation, drawings production, and visualization as well. So it's just an example of the sub-assembly composer, which is would require some visual programming and sometimes kind of scripting so that you will be able to modify the links, the points, and the shapes to interact with one another in certain fashion. Once you're done with all that, like in this case, you create the grading, you check the cut and fill quantities, the volume report for the whole rail track, then you can connect with the estimation software, you get the cost in dollars or Turkish lira or what have you. All types of reports, parametric, you can change, and everything updates. And definitely, as I mentioned earlier, the drawings production. So this is, for example, the final layout of our model, which if we like, we can directly bring into InfraWorks and visualize it in context, if we would like to create maybe some animations or screenshots in 3D. So that's the same alignment we finally detailed inside of Civil 3D. This is how the project will look like in real life. Sometimes we have an existing alignment, and this is where we use some other workflow. So instead of basically designing everything in Scratch, no, we use the point clouds, as we've seen earlier, inside of InfraWorks. We capture those feature lines, as you can see, the blue ones. We specify them as break lines or other features, and then we bring all that in a format that Civil 3D can read, and we can export into too many different formats. Those lines come into Civil, and then we can start the detailed design process. So either or. Either you have an existing rail track, or you're starting from scratch. Whatever the case, there are workflows and tools that will help you do the job. Coordination and review. Inside your InfraWorks model, you can share the model with different designers within your team, but the only limitation out there is that if you're working with a group of engineers, only one person can edit the model at a single time. So let's suppose I'm working with my colleague. If I want to edit, he cannot basically edit the model. Once I'm done, I close the model, he will be able to open it and work on it as well. This was just a technology that was available it's about the iPad app. So we used to push the models from InfraWorks to the iPad app for visualization. That's not supported anymore. And there was another web viewer where people can view the InfraWorks models using the just any web viewer. That's also not available anymore. Just wanted to highlight that. But now we are using the BIM 360 platform, so we can push a light version of the InfraWorks model to the cloud and do the simulation or do some design review. Now, after we're done with the detailed design, we want to check for clashes. I know this is a video that's more related to road design, but inside of Navisworks, we have all the disciplines, the road, the tunnel, the structural, even the utilities underground. And what Navisworks allows us to do as engineers to check for clashes, any problems between those disciplines. So by just activating the clash detective module, I have those material or objects classified. I want to check, for example, the sanitary against the storm, or maybe water against electrical pipes. And automatically, all the clashes will be detected. Once I hit or click on a single clash, it will be shown in the model in 3D. And once I click on that object, I can leverage or use the switchback functionality. If I'm using definitely Autodesk tools like Revit or Civil. So by clicking on that clash, on the switchback, the computer will take me into the authoring tool. In this case, it's going to be Civil 3D in the back end. Will show me where the clash is, so that as a designer, I'll be able to change and then make sure inside of Navisworks that everything is okay. We can do 4D, 5D sequencing of the same rail track project, how we will go on building the rail track, at which, for example, date, time, etc., week. For the construction planning, we can leverage also the visual effects or visual capabilities of InfraWorks to show visually how the construction will be done by taking snapshots or even creating some simulations. So for example, this is just a very simple process of showing how we're going to create a road diversion, and we're going to talk about this deeply in my third session about construction planning. So how we create those, how we do the simulations, and how we can use them to get approvals very quickly. That was the example of a rail track. This is an example of a station. Same thing. We want to analyze as MEP, engineer, structural, or architectural that we don't have any clashes or any issues. And we can also simulate the construction in 4 dimensions of that metro station as well, using the same technology of Navisworks. So Navisworks serves 2 major functions for us: the clash detection and management, and the 4D, 5D simulation. After that, we're able to push the model for automated machine guidance. This is not used in our region, unfortunately. It's used basically in the Nordics and Sweden, Norway, and Finland, where they push the civil 3D model to a computer on the excavation equipment, and that equipment will be driving or excavating based on the instruction given by the computer. So they reduce the number of people working on site. It's more safe because the operator of this equipment will not hit any underground utilities, and they will also achieve higher accuracy because the equipment will go like 1 time or 2 times and get to the exact right level. Let's talk about project experience and visualization. So the same story about Deutsche Bahn, if you check online, they've actually put online some rendered 360 panoramas. And if you have your own mobile and the Google Cardboard, you can just scan this code, the QR code, and you will directly experience the model in a 3D environment. It's a static, yes, meaning you can't move, but at least you can see it 360 degrees. And that can also be done from Navisworks or using 3ds Max. Coming from Civil or InfraWorks, same thing. So available online for you to check later on. Just regarding the animations, it's that easy. So just few clicks, I want to create an animation for a rail track. I just select the rail track, as you can see over there. I specify some parameters, at what speed the train will be moving, at which track I'll be driving, or maybe as a passenger riding. I hit apply, and as you can see in a second, all the keyframes, so create, all the keyframes over here will be created. Once we hit the play button, I'll be driving throughout that rail track at the speed which I have specified. And I can definitely export that model into a video, which you can share with a client or even put in a presentation or upload to YouTube. A sample of a rendered rail track. So this is taken from, let's say, InfraWorks to 3ds Max. You can end up with something like this. I'll skip all this and just show you some of the major success stories. This is really interesting. So Norconsult in Norway, they were actually asked to design a rail network with stations. So they've used BIM from Autodesk. As you can see, that's the rail alignment. They've used BIM throughout the way, and once they developed the BIM models, they sent those BIM models into virtual reality. So what you see over here is actually a virtual reality of the rail track, of the tunnels, of the signboards. And by just wearing the VR headset, the operators or people who will go into the service rooms can actually in real time experience how the things will look like. If maybe they open a cabinet, they need more space to do some maintenance or turn on some switches or go from one place to the other. So the complete model was put into VR, not only for the stations themselves, but also for the rain as well. So as you can see, as if he's the operator of that train, he can look sideways, he can check whatever is going on. The same applies for passengers and all people within the vicinity of that project. And they've moved one step further. They've taken the BIM model, they've used InfraWorks Mobility Simulation, that's another tool, to simulate the movement of people like what we've seen today in the Museum of the Future from Dubai. So they've simulated the movement of people from one place to the other, and they made sure that this station is able to handle all these people or passengers in it at any point in time. And they've actually reported back to Autodesk, and it's available online actually, that they've reduced the time of checking the design and getting the approvals by 50%. Because for the client, it's now very easy to understand what's going on, or if the design is valid or not valid, or has any problems. And finally, document management, as I talked about it earlier, we can push that InfraWorks model or the Civil 3D model to the cloud, and then everybody who has access using a username and password can get to the model, can maybe do some markups, put some comments, or even create some issues and fire an email to some designer to take an initiative. This is the end of the presentation. So if you have any questions, please feel free. We still have some time. Yes, please. Can you speak up a little bit? Or, sorry, do we have a mic?
Can we have the link for the Deutsche Bahn presentation of work?
Yeah. The material I shared with you, it's available online by Deutsche Bahn.
Yes, I'm asking for the link.
The link? Oh, okay, yeah, sure. Okay. Would you mind, once we're done, just give me your email and I'll send it to you. All right. Okay. Any other question? About InfraWorks, about point clouds, Civil 3D, stations, rail tracks, anything? Nothing? Yes?
What about the electrical planning?
Okay, so at Autodesk, we don't have anything specific for electric. We used to have another tool called Autodesk Utility Design, which was able to do basically the poles and the electricity network, the cables, but it's not supported by Autodesk anymore. So it was taken by another company, and but I believe because Civil 3D is an AutoCAD-based product, there are many plugins and third-party add-ons that are available out there for you to subscribe to or install on top of Civil to do that electrical design. That should be not an issue. Okay, perfect, thank you. So if you have any technical questions, feel free to send them to me by email later on, but expect some delay, okay? So I usually reply back, but we really travel a lot. I've been traveling for the past 3 weeks. I slept in my home maybe 4 nights only in the past month. So just expect a week or two and reply, and I'll definitely reply back to you, okay? Tashakkur Lar, thank you for attending today, and hopefully I'm gonna see you on the following sessions.